Find a map of the solar system. Anyone will do. The poster on a classroom wall, the diagram in an old textbook, the picture you carry in your own memory. Now run your eye out to the edge of it, past the giant planets, all the way to Neptune, that last pale dot where the drawing simply stops. That edge is a lie. Beyond the line where the map shows nothing, the solar system does not end. It barely begins. Past Neptune lies a frozen dark so enormous that everything on that map, every planet, every world you have ever heard named, would fit inside a single bright speck at its centre. It is thousands of times larger than the part we know. It is colder than almost anywhere that exists. It is scattered with worlds on orbits that should be impossible, wrapped in a shell of 1 trillion silent comets, and it may be hiding a planet larger than the Earth that we have searched for and failed to find for over 10 years. Tonight, we're going to walk out past that edge together, slowly, one step at a time, into the real solar system, the enormous part that almost no one ever sees. Get comfortable. If you're the kind of person who quietly loves having the size of the world pulled out from under you, a slow like and subscribe genuinely helps this channel reach more curious minds who think the way you do. Because by the end of tonight, that one small word, empty, is never going to sound the same to you again. Now let's slowly settle in. There is a picture of the solar system that almost everyone carries in their head, and it was put there so gently that we never noticed it happening. It is a row of planets, evenly spaced across a page, growing outward from a warm yellow sun. Mercury, then Venus, then the small blue marble we live on, then rusty Mars, then the great banded giants, Jupiter and Saturn, and finally the 2 pale ice giants at the far end, Uranus and Neptune. And then the page stops. There is nothing after Neptune. The diagram simply runs out of room, the way a story runs out of pages, and the lesson we absorb without ever being told it directly is that this is the whole thing. The solar system is the planets. It ends where the last planet orbits, and beyond that final blue dot there is only the empty black of space, the edge of the map, the place where there is nothing left to draw. Tonight I want to take that picture apart, slowly and carefully, because it is one of the most misleading images we are ever handed, and almost every part of it is wrong. Not wrong in some small technical way that only an astronomer would care about. Wrong in the way a map would be wrong if it showed you a single lit room and quietly implied that the room was the entire house, when in truth the house had hundreds of rooms, and the one you were shown was the smallest, and everything else was in darkness. That is the situation we are actually in. The space beyond Neptune is not the edge of the solar system. By almost any honest measure you choose, it is the solar system. It is the overwhelming majority of it, and we have barely seen any of it at all. Let me start with where Neptune actually sits, because the numbers matter here more than usual. Astronomers measure distances inside the solar system in a unit called the astronomical unit, and 1 astronomical unit is simply the distance from the Earth to the Sun, about 150 million kilometers. Light, the fastest thing there is, crosses that gap in a little over 8 minutes. So when you feel the warmth of sunlight on your face, you are feeling light that left the sun 8 minutes ago. Neptune orbits at roughly 30 astronomical units from the sun, 30 times farther out than we are. Sunlight that reaches your skin in 8 minutes takes more than 4 hours to crawl all the way out to Neptune. Out there, the sun is no longer a disk you could point to and call a sun. It is a single fierce point of light, about 900 times fainter than it is here, brilliant against the dark but giving almost nothing back in the way of heat. Now here is the first thing the diagram never tells you. If the solar system truly ended at Neptune, if that 30 astronomical unit mark were the real far wall, then the tidy picture would be honest, and I would have nothing unsettling to say to you tonight. But it does not end there. Neptune is not the far wall of the room. Neptune is the last streetlight on the edge of town, the final point where the light is still strong enough to see by, and past it the road keeps going. It keeps going not for a little way, not for another 10 or 20 astronomical units, but outward and outward through a darkness so wide that we stop measuring it in astronomical units and start measuring it in light years. The farthest reaches of the sun's territory do not lie a few times beyond Neptune. They lie tens of thousands of times beyond it, so far out that a meaningful fraction of the way to the very next star still belongs, faintly, to our own Sun. Everything past Neptune has a name, and the name is deliberately plain. We call it trans-Neptunian, which means simply beyond Neptune. A trans-Neptunian object is any body that orbits the Sun at a greater average distance than Neptune does, and when astronomers first began to seriously look for such things, they were not at all sure they would find anything. The assumption baked into that childhood diagram was so strong that for most of the 20th century the space beyond Neptune was treated as genuinely, boringly empty, a void, a place where the solar system had thinned out to nothing and handed the rest over to the stars. That assumption did not survive contact with the telescope. What we have found instead, piece by piece, decade by decade, is a structure with 3 great parts, and each of those parts was discovered late, discovered reluctantly, and discovered with something close to disbelief. The first part is a flattened ring of icy worlds beginning at Neptune's orbit and reaching out to about 50 astronomical units, a region that turned out to hold Pluto and thousands upon thousands of other frozen bodies. The second part is a wilder scattering of worlds beyond that ring, objects thrown onto enormous elongated orbits, some of which swing out to nearly 1,000 astronomical units and take longer than the whole of recorded human history to circle the Sun a single time. And the third part is the largest and strangest of all, a hypothesized shell of perhaps 1 trillion frozen comets wrapped completely around the solar system, a shell so wide that its outer edge sits a good fraction of the way to Proxima Centauri, the nearest star to our own. Threaded through all 3 of those regions are the mysteries, and this is where the word horrifying in tonight's title earns its place. There is a point in that first icy ring where the objects abruptly stop, a cliff edge in the population that nobody has been able to fully explain. There are worlds out there on orbit so far from Neptune that Neptune could not possibly have placed them there, which means something else did, something we have not identified. There is an ongoing, unresolved hunt happening right now for a planet several times the mass of the Earth that may be hiding somewhere in that outer, dark, unseen, uncaught, for as long as we have been looking. And there is the deepest question of all, the one we will end on tonight, which is where the solar system actually ends, and whether it has an edge at all, or whether it simply fades, without any line to cross, into the space between the stars. There is one more thing worth knowing before we set out, and it is a small piece of history that will matter enormously by the end of tonight. Neptune itself, that last planet on the diagram, was never actually seen by anyone until we already knew exactly where to look. In the middle of the 1800s, astronomers noticed that Uranus was not moving quite the way it should. Its orbit had a slight wobble, a gentle tug pulling it off the path the known planets could account for. A French mathematician named Urbain Le Verrier took that wobble, and with nothing but pencil, paper and the laws of gravity, he calculated where an unseen 8th planet would have to be to cause it. He handed those coordinates to an astronomer who pointed a telescope at that exact spot on the very first night in 1846, and there it was. Neptune had been found not by looking, but by listening to what its gravity was doing to something else. Hold on to that idea. The outer solar system has always been mapped first by the fingerprints gravity leaves behind, and only later by the eye. It is precisely how we are hunting for the next hidden world tonight. To feel the scale honestly, try shrinking the whole thing down. Imagine the Sun reduced to the size of a single grain of sand. On that scale, the Earth is an almost invisible speck sitting about 1 centimetre away, and Neptune, our supposed far wall, is roughly 30 centimetres out, about the length of your forearm. That is the entire familiar solar system, the whole diagram, fitting comfortably on a desk. Now here is the part that should make the floor feel less solid under you. On that same grain of sand scale, the outer shell of frozen comets we are going to reach tonight would not be on the desk. It would not be in the room. It would be somewhere out past the edge of your town. The map you were given showed you the desk and called it the universe. I want to walk you all the way out through this tonight, one careful step at a time, from the last blue dot on the map to the place where the Sun finally loses its grip on the dark. And I will tell you now what we're going to find at every single step of that walk, because it is the same discovery, made over and over, each time larger than the last. We were told this space was empty. It is not empty. It is dark, and it is cold, and it is slow, and it is unimaginably far, and those 4 things together are very good at hiding a place. but hidden is not the same as absent. The edge of the map was never the edge of the world. It was only the edge of what we had bothered to draw. So let us go past it, past that final streetlight, and see what has been waiting out there in the dark the entire time. Let us take the first step past Neptune and see what has been hiding just beyond that last streetlight. The region that begins at Neptune's orbit and reaches outward to about 50 astronomical units is called the Kuiper Belt, and it is the closest of the three great parts of the outer solar system. If you keep the grain of sand model in your head, the Kuiper Belt is the ground immediately beyond your forearm's reach on the desk, a broad, flattened ring of frozen worlds circling the Sun in the same rough plane as the planets. It is shaped a little like a donut, thick with objects, and for most of the 20th century we had no proof that a single one of them existed. The strange thing is that we suspected it long before we found it. Back in the 1940s, an astronomer named Kenneth Edgeworth wondered aloud whether the solar system really just stopped at Neptune, or whether there might be a reservoir of smaller bodies scattered out beyond it, left over from the making of the planets. A few years later, in 1951, Gerard Kuiper wrote about the same region, and it is his name that ended up attached to it, though some astronomers, wanting to be fair, call it the Edgeworth-Kuiper Belt. Here is the irony that tells you how deeply the empty edge assumption ran. Kuiper himself actually argued that while such a belt of objects might have formed early on, it should have been cleared out and scattered away by now so that today the region would be empty. The man the belt is named after thought the belt was no longer there. For decades nobody could prove him wrong, because these objects are almost impossibly hard to see. They are small, they are dark, coated in ancient reddened ice and dust that reflects very little light. And they are so far away that the light they do reflect, the feeble scraps of sunlight that reach them and bounce back, has to cross billions of kilometers before it ever arrives at a telescope. Finding one is like trying to spot a lump of charcoal at the far end of a dark stadium by starlight. It took until 1992, well within a single human lifetime, for two astronomers named David Jewett and Jane Liu to finally catch one, after 5 patient years of searching. The object they found was given the plain catalogue name 1992, QB1, and it was later named Albion. It was a frozen world a couple of 100 kilometers across, exactly where the belt was supposed to be, and its discovery changed everything. In a single observation, the space beyond Neptune went from theory to fact. The empty edge of the map was not empty after all. Once we knew what to look for, the floodgates opened. We have now catalogued more than 3,000 of these Kuiper Belt objects, and that is only the tiniest sample of what is actually there. Astronomers estimate that the belt holds more than 100,000 objects larger than 100 kilometers across, and likely hundreds of millions of smaller ones down to the size of comets. This is not a scattering of stragglers. It is a genuine population, far more numerous than the familiar asteroid belt between Mars and Jupiter, spread across a ring billions of kilometers wide. And moving among these countless frozen bodies are worlds large enough to be counted as dwarf planets in their own right. Worlds you may have heard named without ever being told where they truly live. Haumea, a strange elongated world spinning so fast that it has stretched itself into the shape of an egg, and which even carries a thin ring. Make. Quaoar, which has a ring of its own that current theory says should not be able to exist where it does. Orcus, sometimes called the anti-Pluto because it circles the Sun in a mirror image of Pluto's own path. Each of these is a real place, with its own surface and its own history, sitting out there in the cold this entire time. The belt is not a shapeless jumble either. The more we mapped it, the more we found it had structure, and that structure is written by the gravity of Neptune reaching out from the inside. Most of the objects fall into a few families. There are the classical objects, sometimes nicknamed cubawanos, which drift along on relatively calm, nearly circular orbits between about 42 and 48 astronomical units, far enough from Neptune to be left largely in peace. And then there are the resonant objects, worlds whose orbits are locked in a precise rhythm with Neptune's, like two dancers keeping time. The most famous of these are the Plutinos, named after their leader, and Pluto itself is the leader. Pluto is caught in what astronomers call a 3-to-2 resonance with Neptune, which means that for every 3 times Neptune circles the Sun, Pluto goes around exactly twice. That locked rhythm is what keeps the two worlds from ever colliding, even though Pluto's tilted, stretched orbit actually crosses inside Neptune's path for part of each loop. The timing is arranged so that whenever Pluto swings closest to the Sun, Neptune is always somewhere far away on the other side. Thousands of other Plutonos keep that same beat, shepherded into step by a planet none of them will ever touch. To put the population in perspective, the Kuiper belt is not a smaller cousin of the asteroid belt. It dwarfs it. There are perhaps 100 times more large objects out past Neptune than there are in the entire asteroid belt between Mars and Jupiter, and the belt is spread across a region billions upon billions of kilometers wide. The total mass of everything in it adds up to only a few % of the mass of the Earth, but that mass is not concentrated. It is scattered across a volume so enormous that the objects rarely come anywhere near one another, each one circling in near total isolation, most of them never yet seen by human eyes, and the colour of these worlds tells its own quiet story. Many of them are deeply red, stained by what chemists call tholins, complex organic compounds built up over billions of years as the faint ultraviolet light of the distant sun slowly works on the ices at their surfaces. They are not the clean white snowballs we might picture. They are dark, ancient and rust-coloured, the shade of dried blood drifting in the cold. But the anchor of the whole region, the world that shows us most clearly how wrong the phrase dead frozen rock turns out to be, is Pluto. For most of the last century, Pluto was thought of as the 9th planet, and then, in 2006, in a decision that still makes people angry, it was reclassified as a dwarf planet, in large part because we had begun to realise just how many Pluto-like bodies were out there in the belt with it. But whatever we choose to call it, Pluto orbits at an average of about 39.5 astronomical units, out in the thick of the Kuiper belt, and for almost all of human history it was nothing more than a faint dot, a point of light too small to resolve into anything at all. We had no idea what its surface looked like. Most people assumed the obvious. A tiny world that, far from the sun, receiving about 1/1600th of the sunlight the Earth gets, with a surface temperature down around 40 degrees above absolute zero, would surely be a frozen, cratered, geologically dead ball of ice. A corpse. Nothing out there could possibly still be alive in any meaningful sense. Then, on the 14th of July in 2015, a small spacecraft the size of a piano called New Horizons flew past Pluto after a journey of 9.5 years and nearly 5 billion kilometers, and it sent back photographs that no one had predicted. Pluto was not dead. It was one of the most surprising worlds in the entire solar system. Across its surface stretched an enormous heart-shaped plain, and the left lobe of that heart, a region now called Sputnik Planitia, turned out to be a basin nearly 1,000 kilometers wide, filled with glaciers of frozen nitrogen, and those glaciers were moving. The surface of Sputnik Planitia has almost no impact craters on it at all, which for a planetary scientist is an unmistakable signal, because craters accumulate over billions of years, and a surface with none is a surface that is being constantly renewed. Something is resurfacing Pluto from within. The nitrogen ice is slowly churning, welling up and sinking back down in great slow convection cells, wiping the surface clean on a world so cold that nitrogen, the gas that makes up most of the air you're breathing right now, lies frozen solid on the ground. There was more. New Horizons found mountains on Pluto, jagged ranges standing several kilometers tall, and those mountains are made of water ice, because at 40 degrees above absolute zero, water ice is not soft or slushy. It is hard as rock, hard enough to build mountains that keep their shape. It found a thin, layered blue haze hanging in Pluto's tenuous nitrogen atmosphere, glowing in the backlit sun. And from the position and behaviour of that great nitrogen basin, some scientists have made an even bolder argument that beneath Pluto's frozen shell there may be a hidden ocean of liquid water, kept from freezing by the slow heat leaking out of the little world's rocky heart. A liquid ocean, on a world we had written off as a frozen corpse, in a part of space we had labelled empty. And Pluto does not travel alone. It has 5 known moons, and the largest of them, Charon, is so big relative to Pluto, roughly half its diameter, that the two of them do not really orbit as a planet and a satellite at all. Instead, they circle a shared point of balance that sits in the empty space between them, so that the two worlds are permanently locked facing each other, turning together like the ends of a slow dumbbell as they fall around the distant sun. From the side of Pluto that faces Charon, the moon would hang enormous and motionless in the sky, never rising and never setting, always in the same place. New Horizons found Charon to be its own strange world, with a dark reddish cap at its north pole, stained, we think, by gases that drifted off Pluto and froze onto its companion. Even the smaller moons, with names like Nix and Hydra and Styx and Kerberos, turned out to be oddly shaped and tumbling chaotically, unable to settle into any steady spin. This was not a lonely dot at the edge of nowhere. It was a whole miniature system, a family of worlds, waiting in the dark for someone to finally come and look. I want you to sit with what that means, because it sets the tone for everything still to come tonight. The very first world we visited beyond Neptune, the closest and most accessible object in the entire outer solar system, the one we were most confident would be a dead and boring ball of ice, turned out to be geologically alive, with flowing glaciers and towering mountains and possibly a buried sea. And we only learned this in 2015. If that is what the first room in the dark contains, the room right next to the ones we know, then the phrase "it's not empty" stops being a reassurance and starts becoming something closer to a warning. Because if the nearest and easiest part of this space could hide a living world from us until a decade ago, we should be very careful about what we assume is waiting in the rooms further out, the ones we have not visited, the ones we can barely see at all, and there is a problem waiting for us at the far side of this first room, a strange edge where the objects suddenly stop that nobody has ever managed to explain. As we followed the Kuiper belt outward from Neptune, mapping object after object, something began to appear in the data that no one had asked for and no one could explain. The belt does not simply thin out gradually the way you might expect. It does not fade politely, growing sparser and sparser until you can no longer tell where it ends. Instead, at a distance of somewhere around 47 to 50 astronomical units from the Sun, the objects almost completely stop. The population falls off a cliff. Astronomers actually call it the Kuiper Cliff, and it is one of the quiet, unresolved, unsettling facts of the outer solar system, because there is no agreed reason for it to be there at all. Let me be precise about why this is so strange. When we build models of how the belt should have formed out of the leftover icy debris of the young solar system, those models predict a disk that tapers off smoothly. There should be a scattering of objects continuing well past 50 astronomical units, growing thinner but still present, trailing away into the dark. That is not what we see. What we see is a fairly rich, well-populated belt of classical objects that reaches out to about 48 astronomical units, and then, over a remarkably short span of distance, the numbers collapse to almost nothing. It is as though you were walking through a crowded room shoulder to shoulder with people, and then took a single step and found yourself completely alone, with an empty floor stretching away in front of you, and no wall to explain why everyone had stopped. So what carved that edge? This is where honesty matters, because the truthful answer is that we do not know. But we have several serious candidates, and each of them is unsettling in its own way. The first possibility is that the edge is a scar left by another star. The Sun was not born alone. Stars form in crowded stellar nurseries, clusters of hundreds or thousands of young suns packed relatively close together, and in that crowded infancy it is entirely plausible that another star passed close enough to the young Sun to gravitationally strip away the outer part of our forming disk, truncating it, slicing the belt off at a certain radius, and flinging the material beyond into interstellar space or scattering it onto wild orbits. If that is what happened, then the Kuiper Cliff is a fossil of a violent encounter with a sibling star we will never identify, a permanent mark left by a stranger who brushed past us 4.5 billion years ago. The second possibility is stranger, and it is the one that connects most directly to the darkest question we will reach later tonight. Perhaps the belt does not end at the cliff at all. Perhaps the objects beyond it are simply there but too faint and too far for our surveys to reliably detect, and the cliff is not a real edge but an artifact of the limits of our telescopes. This is a real and actively debated idea, and every so often a new object turns up further out than the cliff, hinting that the population might resume, that there might be a second belt or an extended tail that we have only barely begun to sample. If that is true, then the emptiness beyond 48 astronomical units is not emptiness. It is a blind spot. It is a place we have decided is empty, mostly because we cannot see into it well enough to prove otherwise. And there is a third possibility, the one that should make you sit up. Perhaps something out there sculpted the edge, in the same way that Neptune's gravity shepherds the Plutinos into their locked rhythm. A large enough unseen body, orbiting beyond the belt, could have gravitationally cleared or truncated the outer classical objects, herding them, cutting the population off at a certain line. a shepherd we have not found. I am not going to claim tonight that the Kuiper Cliff proves the existence of a hidden planet, because it does not, and the stellar flyby explanation may well turn out to be correct. But I want you to notice a pattern that is going to repeat, growing stronger each time. Again and again, when we look at the outer solar system, we find structure that looks as though it was shaped by something, edges that are too sharp, orbits that are too aligned, patterns that do not arise from nothing, and every time we are left holding the same question, the question that will define the second half of tonight. Did the emptiness make this shape on its own, or did something in the dark reach out and carve it? There is a piece of backstory that makes the cliff feel even less like an accident, and it has to do with how violent the early outer solar system actually was. The belt we see today is not the belt that first formed. When astronomers try to reconstruct the original population, the primordial Kuiper belt, they conclude it must have been far more massive than what remains, perhaps tens of times more massive, holding enough material to build several more Earths. Almost all of it is gone. The leading explanation is a chapter of solar system history sometimes called the Nice Model, named for the French city where it was developed, and it describes a period early on when the giant planets did not sit quietly where they are now. They migrated. Neptune in particular drifted slowly outward, ploughing into the disk of icy debris beyond it, and as it moved, it scattered that debris in every direction, flinging the great majority of the original belt away, some of it hurled into the sun or the giant planets, some of it thrown clear out of the solar system entirely, and some of it lifted onto the enormous stretched orbits we're about to meet. So the belt we map today is not a pristine leftover, it is a survivor. It is the small remaining fraction that happened not to be thrown away when the giant planets rearranged themselves, and its structure, including that abrupt outer cliff, still carries the fingerprints of that ancient upheaval. When you look at the Kuiper belt, you're not looking at something calm and untouched. You're looking at the aftermath of a catastrophe we did not witness, the quiet, frozen debris field left behind after the outer solar system tore itself into its present shape. And the strangest survivors of that upheaval are not in the belt at all. They are the ones that got thrown the farthest, out onto orbits so extreme that they should terrify anyone who takes the time to understand what those orbits actually mean. For now, stand with me at the cliff's edge and feel where we actually are. We have taken exactly one step past Neptune. We have crossed a single one of the three great regions of the outer solar system, the nearest and the smallest of the three, and already it has given us thousands of frozen worlds, a living dwarf planet with glaciers and mountains and possibly a hidden ocean, and an unexplained edge that may be the scar of a passing star or the shadow of a hidden one. And here is the part that should quietly rearrange your sense of scale. That entire crowded belt, everything we have talked about so far from Neptune at 30 astronomical units out to the cliff at 50, is still, in the full picture of the solar system, almost nothing. We have not left the neighbourhood. We have not even reached the places where the strangest worlds live, the ones on orbits so enormous that they treat this whole belt as a tiny bright centre to fall toward and swing away from. The cliff feels like an ending. It is not an ending. It is the last familiar landmark before the ground truly opens up beneath us, and the objects we meet next are going to be far harder to explain than an unmarked edge in the dark. Because just past this cliff, the neat flattened disk of the belt gives way to something with no clear shape and no clear rules, a scattering of worlds thrown onto tilted plunging paths, some of which do not seem to obey the geography of the solar system as we understand it at all. And before we can even reach the truly distant objects, we have one more visit to make, to the most far-flung world any spacecraft has ever touched, a frozen relic that has been waiting, unchanged, since before the Earth had oceans. After New Horizons flew past Pluto in 2015, it did not stop. It could not stop. A spacecraft crossing the outer solar system carries an enormous speed that there is no way to shed. So once it had photographed Pluto and its moons, it simply kept going, deeper into the Kuiper belt, and the mission team began searching for something else it might be able to reach. They found a target, a tiny object, only about 36 kilometers across, orbiting far out in the classical belt at roughly 44 astronomical units from the Sun, with the plane catalogue name 2014 MU69. It would later be given the name Arakoth, a word meaning sky in the language of the Powhatan people, and on the first day of January in 2019, New Horizons flew past it, making Arrokoth the most distant object any spacecraft built by human hands has ever visited. It is worth pausing on what a journey like that actually requires, because it tells you how far away these places really are. New Horizons launched from Earth in January of 2006, and it left our planet faster than any spacecraft ever had, moving so quickly that it crossed the Moon's orbit in only about 9 hours, a distance that took the Apollo astronauts 3 days. It then flew all the way out to Jupiter and used the giant planet's gravity like a slingshot, stealing a little of Jupiter's orbital motion to fling itself faster still toward the outer solar system. And even moving at that tremendous speed, even with the fastest launch in history and a boost from the largest planet, it still took 9.5 years just to reach Pluto, and another 3.5 years beyond that to reach Arrokoth. 13 years of flight to cross a region that, on our grain of sand model, would still fit on a large desk. That is the first honest taste of the scale we're dealing with, and we have barely started. What it found there was, in its own quiet way, even more important than Pluto. Arrokoth is what astronomers call a contact binary. It is made of 2 separate lobes, one larger and one smaller, joined at a narrow neck, so that the whole thing looks unmistakably like a small reddish snowman drifting in the dark. And the crucial thing about Arrokoth is that it is pristine. It has been almost completely undisturbed since the solar system formed. Out there, so far from the sun, so far from any other body, there is nothing to erode it, nothing to melt it, nothing to smash into it with any real frequency. It has simply hung in the great cold, essentially unchanged, for around 4.5 billion years. When we look at Arrokoth, we are not looking at a weathered, battered survivor like most of the objects closer to the sun. We are looking at a building block of the solar system, frozen in the exact state it was in before the planets finished forming, before the Earth existed, before there was an ocean or an atmosphere or a single living cell anywhere in the universe that we know of. The surface itself carried the marks of that great age. Arrokoth is deeply red, even redder than most of the belt, and the colour comes from those same tholins, the complex organic molecules built up over billions of years of faint radiation, working on frozen methanol and other ices. Curiously, the instruments found little sign of water ice on the surface, which is not what anyone expected, and the 2 lobes turned out to be surprisingly flat, more like a pair of pressed pancakes than round balls, a shape that hints at how gently the original cloud of material must have settled together. Every one of these details is a clue to the very first chapter of the solar system's story, a chapter that has been erased almost everywhere else. On Earth, plate tectonics and weather and life have destroyed nearly all the rock that dates from the beginning. On Arrokoth, the beginning is the surface. Nothing has come along to bury it. The way its 2 lobes are joined told us something we had argued about for decades, which is how the very first solid bodies in the solar system came together. If planetesimals like this had formed through violent high-speed collisions, Arrokoth would show the damage. It would be shattered, cratered, deformed. Instead, its 2 lobes appear to have come together slowly and gently, drifting into contact at little more than walking speed and simply sticking, which supports a gentler picture of planet formation, in which small bodies condense out of slowly collapsing clouds of pebbles, rather than being hammered together in a shooting gallery. Arrokoth is, in effect, a photograph of the beginning, preserved by cold and distance and left untouched for us to find. And I want you to actually be there for a moment, because a number on a page does not do it justice. Picture yourself riding alongside that spacecraft in the first hours of the new year. You're more than 6 billion kilometers from home, so far that a radio signal, travelling at the speed of light, takes 6 hours to reach you from Earth and 6 hours to return, so that any message is already half a day old by the time it lands. The sun is behind you, and it is no longer a sun in any sense you would recognize. It is a single hard white star, brighter than all the others but small enough to hide behind a raised fingertip, and it gives off no warmth that you could ever feel. Ahead, out of the blackness, a shape begins to resolve. At first it is just a smudge, a reddish point slightly brighter than the dark around it. Then it grows, and it takes on form, and you see it, the 2 joined lobes, the narrow waist, the gently rounded ends, turning slowly against a sky with more stars than you have ever seen, because there is no air and no sunlight to wash them out. This little world has been turning like this, in silence, in this exact place, since before the continents, since before the oceans, since before anything on Earth was alive. It is not a ruin. Nothing here ever fell into ruin, because nothing here ever changed. It is a survivor of the very first days, and you are the first eyes ever to see it. And here is the thought that should stay with you as we move on. Arakoth is not special. It is not a rare specimen. It is simply the one small frozen body that happened to lie close enough to New Horizons' path that we could steer toward it and take its picture. There are, by every estimate, hundreds of millions of objects like Arakoth scattered through the Kuiper Belt and beyond it uncounted more. Each one is its own pristine relic, its own frozen photograph of the beginning, turning slowly in the dark, and we have visited exactly one of them. We reached out across 6 billion kilometers, brushed a single grain of the outer solar system with a single glance, and found a perfectly preserved fragment of the dawn of everything. Then the spacecraft flew on, and that one grain fell back into the darkness behind it, and all the others, the hundreds of millions of them, remain exactly where they have always been, unseen, unnamed, unvisited, waiting. When someone tells you the space beyond Neptune is empty, this is one of the images to hold against that claim. It is not empty. It is a museum of the origin of the world, and we have walked past a single exhibit with a flashlight and called the whole building dark. That is what the great cold does out here, and it is one of the quietly frightening truths of the outer solar system. Closer to the sun, time erases things. Surfaces are cooked by sunlight, ground down by micrometeorites, reshaped by heat and impact, and, on a world like ours, by wind and water and life. The past gets overwritten. But out beyond the cliff, in the great cold, nothing is overwritten, because nothing has the energy to change. The past does not fade there, it simply stays. Arakoth today looks essentially the way it looked before the Earth was born, and it will go on looking that way, unchanged, long after the Earth is gone. There is something deeply unsettling in that. The idea of a place where 4.5 billion years can pass and leave no mark, where the abyss of time itself seems to stop. And Arakoth, remember, is still one of the near objects. It sits at 44 astronomical units, just past the cliff, well within the first of our 3 great regions. We have still not reached the worlds that fall inward from truly far away, the ones whose orbits make no sense, the ones that carry, written into their paths, the signature of something we have never seen. Up to now, everything we have met can be explained by the solar system we know. The belt, the cliff, the pristine relics, even the ancient upheaval that shaped them all, fit inside the story of a sun and its planets and their leftover debris. That comfortable fit is about to break. The next objects we meet do not belong to any tidy story. They are out on paths so long and so strange that the planets we know could not have put them there, and once you understand what that implies, the darkness beyond the cliff stops feeling merely large and starts feeling occupied. That is where we go next, and it is where the real unease begins. Beyond the cliff, the neat flattened disk of the Kuiper Belt gives way to something with no clear shape. The first family of objects we meet here is called the scattered disk, and the name is honest about how these worlds came to be. These are bodies on stretched eccentric orbits, often steeply tilted out of the plane of the planets, that swing far out into the dark and then come plunging back inward. The key feature of a scattered disk object is that at its closest approach to the Sun, its perihelion, it still comes reasonably near to Neptune's orbit, somewhere around 30 to 38 astronomical units, and that closeness is the explanation. These are the objects Neptune threw. During that ancient upheaval, when the giant planets were rearranging themselves, Neptune's gravity flung these bodies outward onto their wild, elongated paths, and each time one of them falls back inward, it still passes close enough to Neptune to feel that same gravitational hand. Their orbits are extreme, but they make sense. We can trace them back to a cause we understand. The largest of these scattered objects is a world called Eris, and Eris deserves a moment of your attention, because it is the world that got Pluto demoted. Eris was discovered in 2005 by a team led by the astronomer Mike Brown, out on an orbit that carries it as far as about 96 astronomical units from the Sun. When they measured it, they found something startling. Eris is slightly more massive than Pluto. Here was another world, out past the belt, that was essentially Pluto's twin in size and heft, and it forced an uncomfortable question. If Pluto was a planet, then Eris had to be a planet too, and so did any number of other large round bodies we were finding out there. Rather than keep adding planets to the list, the astronomical community chose instead, in 2006, to define a new category, the dwarf planet, and both Pluto and Eris were placed into it. Eris even has its own moon, named Dysnomia. So the demotion that upset so many people was not really an insult to Pluto. It was an admission that the outer solar system had turned out to be far more crowded with substantial worlds than anyone had planned for. But the scattered disk, strange as it is not where the real mystery lives. The real mystery begins with a second group of objects, a rarer and far stranger group, and these are the ones that broke the tidy story. They are called the detached objects, and the sednoids, and what makes them extraordinary is a single fact. At their closest approach to the Sun, they never come anywhere near Neptune. Their perihelia are not at 30 or 35 astronomical units. They are far, far beyond that, out where Neptune's gravity is much too weak to have any effect. And yet their orbits are enormously stretched, carrying them out to hundreds or even thousands of astronomical units. This is the contradiction that should stop you. An extremely elongated orbit is a scar. It is the mark left by a violent gravitational encounter, something that grabbed an object and flung it far out into the dark. But the only body massive enough and close enough to have done that flinging, out in this part of the solar system, is Neptune. And these objects never go near Neptune. So what stretched their orbits? What reached out far beyond the planets and through these worlds onto paths that no known planet could have made? The first and most famous of these impossible worlds is Sedna. Sedna was discovered on the 14th of November in 2003 by Mike Brown, Chad Trujillo, and David Rabinowitz, and its orbit is genuinely difficult to comprehend. At its closest approach to the Sun, Sedna is about 76 astronomical units out. Let me say that again, because it is the whole point. Its closest approach, the nearest it ever gets to the Sun, is more than twice as far as Neptune. It never comes into the region where Neptune could touch it. And from that already distant closest point, its orbit stretches outward to an aphelion, a farthest point, of around 936 astronomical units. To travel that enormous loop just once takes Sedna roughly 11,400 years. Think about what that number means. The last time Sedna was as close to the Sun as it is now, human beings were only just beginning to plant the first crops, at the very dawn of agriculture, before the first cities, before writing, before recorded history of any kind. It has been out in the dark for the entire span of human civilization, and it is only now, around the year 2075 or 2076, coming back to its closest point. We happen to discover it during the tiny sliver of its 11,000-year journey, when it is near enough to see it all. Miss that window, and we would not have known it was there for another 11,000 years. Sedna itself is a genuinely strange object to look at, in the little we can tell. It is roughly 1,000 kilometers across, a small world in its own right, and it is one of the reddest objects in the entire solar system, nearly as red as Mars, its surface coated in ancient organic ices, darkened by billions of years of faint radiation. It turns very slowly, and it is so far away and so faint that even now, near the closest approach it will make for 11,000 years, it sits at the very limit of what our telescopes can resolve. We know its orbit far better than we know the world itself, and that gap between how precisely we can chart its path and how little we can see of the object tracing it is the whole condition of the outer solar system in miniature. Out here, the orbits speak more loudly than the objects. We can read where something has been and where it is going long before we can see what it actually is. Sedna, it turns out, is not alone. In 2014, astronomers found a second world of the same kind, an object called 2012 VP113, informally nicknamed Biden, with a closest approach of about 80 astronomical units, even farther from Neptune than Sedna. Then came another, 2015 TG387, given the wonderful name Lelekuhonua and the nickname the Goblin, with a perihelion around 65 astronomical units and an orbit reaching out past 2,000. Each of these discoveries deepened the same problem. Here was a whole class of worlds, out beyond the reach of every planet we know, on orbits that only a powerful, distant gravitational influence could explain. And when astronomers began to plot those orbits carefully, they noticed something about them that turned an interesting puzzle into one of the most talked about mysteries in modern astronomy. The orbits did not point in random directions, they seemed to line up. But we will come to that alignment in its proper place, because it is the heart of the hunt for a hidden planet, and it deserves the full weight of the second half of tonight. It is worth walking slowly through the suspects, because each one is unsettling in a different way. The first is a passing star. The Sun, as we said, was born in a crowded cluster, and in those early few 100 million years another star could easily have swept close to our system, close enough that its gravity reached in and lifted the perihelia of the outermost objects, dragging their closest approaches away from the planets and leaving them stranded on detached orbits. If that is the answer, then Sedna is a keepsake from a stranger, a world rearranged by a star that vanished into the galaxy billions of years ago and that we will never identify. The second suspect is the birth cluster itself, the combined gravity of all those sibling stars gently tugging on the Sun's outer debris before the cluster dissolved. The third suspect is a rogue planet, a world drifting through interstellar space after being ejected from its own system, that passed through the young solar system and stirred the outer objects before moving on. And the fourth suspect is the one that refuses to go away, a large planet that did the flinging and that is still out there, still bound to the Sun, still orbiting somewhere in the dark, unseen. 4 suspects, and we cannot yet rule any of them out. But notice that 2 of the 4, the rogue planet and the hidden planet, involve a world we have never catalogued. Half of the plausible explanations for Sedna's orbit require an object that, as far as our maps are concerned, does not exist. For now, I want you to sit with the raw strangeness of Sedna itself, because there is a realization buried in it that is easy to walk past and worth stopping for. An orbit is not just a path. An orbit is a record. It is a fingerprint. The precise shape of the loop a world traces, how stretched it is, how tilted, where its closest and farthest points fall, is the frozen memory of every force that has ever acted on it. And when you read Sedna's fingerprint, it says something plainly, something that does not depend on any theory or speculation. It says that at some point in the distant past, something reached out into the dark, far beyond the planets, and took hold of this world, and pulled its orbit into a shape that the known solar system cannot account for. We do not know what that something was. It might have been a star that passed close to the young Sun during its crowded birth, long since drifted away into the galaxy. It might have been the Sun's own birth cluster, tugging on its outer objects before dispersing. It might have been a large body that still exists, still out there, still orbiting in the dark. But whatever it was, Sedna carries its signature. The emptiness beyond Neptune is not shapeless and inert. It has a shape, and the shape was pressed into it by a hand we have never seen. That is a different and more disquieting kind of not empty than anything we have met so far. It is one thing for the dark to be full of frozen worlds. It is another thing entirely for those worlds to be arranged, for their very orbits to point, like a compass needle, towards something hidden. We are used to thinking of empty space as passive, as the absence of things, as the part of the map where nothing is happening. Sedna quietly overturns that. Sedna tells us that the outer dark has a history, that events unfolded there, that forces moved through it and left marks that persist for billions of years. The loop it traces is not random. It was made. And a made thing implies a maker, even when the maker is long gone or has never been seen. Every time you picture Sedna crawling along that 11,000-year loop, remember that the loop itself is evidence, hanging in the dark, of something that happened out there before there were any human eyes to witness it. And we are still only at the inner edge of the truly remote regions. The farthest point of Sedna's orbit, that lonely aphelion at 936 astronomical units, is where we are headed next, and standing there changes everything about how large this place really is. It is one thing to read the number. It is another to stand on that frozen ground, look back toward the Sun, and try to find it among the other stars. Let us stop here for a moment, halfway through our walk, and put the pieces we have gathered back together, because it is easy to lose the sense of scale when the numbers keep growing, and the scale is the whole point tonight. So let us step back and count our steps out from the Sun, slowly, one at a time, and feel how far we have actually come, and how far we still have to go. We began at Neptune, 30 astronomical units from the Sun, at the last streetlight on the edge of the diagram, the place where the childhood map runs out. That felt like the edge. It was not the edge. We took a step past it, into the Kuiper belt, and found not emptiness but a broad ring of thousands upon thousands of frozen worlds reaching out to 50 astronomical units, with Pluto living among them, geologically alive, glaciers moving across its surface, mountains of rock-hard ice, possibly a hidden ocean beneath its shell. The belt felt like the outer solar system. It was not the outer solar system, it was the first room. At its far side we found the cliff, that unexplained edge at 50 astronomical units where the objects abruptly stop, which felt like it might finally be the true boundary. It was not the boundary. Beyond it we visited Arakoth, the most distant thing we have ever touched, a pristine relic from before the Earth was born, and past it we found the scattered worlds, and then the detached ones, Sedna on its 11,000-year loop out to 936 astronomical units, on an orbit that no known planet could have made. Now hold all of that in your mind at once, and here is the thing I need you to feel. Everything I have just described, the entire journey so far, from Neptune at 30 astronomical units all the way out to Sedna's farthest point at 936, everything we have seen tonight is still, in the true picture of the solar system, only the beginning. We are not halfway, we are not a tenth of the way. Sedna's aphelion, that impossibly remote point where a world spends thousands of years in near-total darkness, is where the next region, the true bulk of the solar system, is only just getting started. The greatest of the three great parts, the one that holds most of the objects the Sun owns and reaches most of the distance to the next star, lies entirely beyond everything we have discussed. We have been walking for what feels like a very long time, and we have crossed the small bright centre and taken our first steps into the middle distance, and the map in front of us is still almost entirely blank. Go back to the grain of sand for a moment, because it anchors this better than any raw number can. On that model, with the Sun shrunk to a single grain, the Earth was a centimetre away, and Neptune was about 30 centimetres out. The length of your forearm and the whole familiar solar system fit on a desk. Sedna's farthest point on that same scale is not on the desk anymore. It is across the room. And the outer shell of comets we are about to reach, the true edge of the Sun's domain, is not across the room. It is out past the edge of your town, kilometres away, while the Earth and everything you have ever known sits as an invisible speck 1 centimetre from a grain of sand on a desk somewhere behind you. That is the correct shape of the place you live. Almost all of it is dark, almost all of it is cold, almost all of it is so far away that the objects out there take thousands of years to complete a single orbit, and we have mapped only the tiny bright grain at the very centre. There is another way to feel this scale, and it uses light instead of distance. Light is the fastest thing that exists, and it reaches your face from the Sun in about 8 minutes. It takes a little over 4 hours to crawl all the way out to Neptune. By the time it reaches Sedna at its farthest point, sunlight has been travelling for more than 5 days, and to reach the outer edge of the shell we are about to enter, that same sunlight, moving at the ultimate speed limit of the universe, needs about a year and a half. Sit with that. A beam of light leaving the Sun today would still be travelling outward through the Sun's own territory a year and a half from now, and only then would it reach the far edge of what the Sun holds. The solar system is not a place light crosses in minutes. Its true extent is measured in years of light, which is exactly the unit we use for the distances between the stars themselves. That is how we know, without any further argument, that the outer solar system is not a footnote to the planets. It is a structure on the scale of interstellar space, wearing the Sun's name. And through every step of this recap, the same 3 words keep returning, quieter and heavier each time. It's not empty. The belt was not empty. The cliff was not the end. The scattered dark was not shapeless. Sedna's orbit was not random. At every single stage, the thing we were taught to expect, nothing, turned out to be wrong, and what we actually found was more worlds, more structure, more evidence of forces at work. Keep that phrase close, because in the second half of tonight it stops being a series of pleasant surprises and starts becoming something with real weight behind it. I wanted us to pause and feel that, because the second half of our walk goes somewhere the first half only hinted at. So far the strangeness has been about scale and cold and unexplained edges. From here on, it becomes something more. We are going to walk into a region we have never actually seen, a shell we know exists only because of the things it occasionally sends us. We are going to meet the messengers it sends, the comets, and understand where they truly come from. We are going to watch other stars pass close enough to reach into it, and then we are going to confront the possibility that a planet, a real planet larger than the Earth, is hiding somewhere out there in that dark right now, and that despite everything, despite all our telescopes and all our searching, we still cannot find it. Take a slow breath. We are only halfway. The largest and least known part of your own solar system is still ahead of us, and it is where the deepest unease lives. Everything from here on shares one uncomfortable quality that the inner regions did not have. Up to now, we have been walking through places we can, at least in principle, see, worlds we have photographed, orbits we have charted, a spacecraft we sent to touch the farthest of them. From here on, we walk into regions we have never directly observed at all, and we will be navigating almost entirely by inference, by the faint clues that reach us from a darkness we cannot look into. So settle in, and let us take the next step outward, into the great shell of comets that no human eye has ever seen. Between the scattered worlds and the great shell of comets waiting further out, there is a region that comes closest of anywhere to deserving the word empty, and it is worth walking through slowly because it teaches us what the outer dark actually feels like. This is the long gap between roughly 50 astronomical units out at the cliff and roughly 2,000 astronomical units where the innermost edge of the comet shell begins. Across that enormous span, objects are genuinely sparse. The only worlds we find crossing it are the detached ones like Sedna on their long plunges inward and outward, spending most of their 11,000-year lives out here in the great cold before making their brief pass near the sun and swinging away again. If you are looking for a place where the solar system really does thin out toward nothing, this middle distance is the closest thing to it. And yet even here, it is not that nothing exists. It is that the somethings are so far apart and so faint that the space between them swallows them whole. Let me tell you what it is actually like out here, because the numbers alone do not carry it. The first thing is the cold. In the Kuiper belt, surface temperatures sit around 40 to 50 degrees above absolute zero, cold enough that nitrogen freezes solid on the ground. But out in the far scattered disk and beyond it, temperatures fall further still, towards single digits above absolute zero, only a few degrees above the coldest temperature that is physically possible anywhere in the universe. Absolute zero, the point at which all heat vanishes, is about 273 degrees below zero on the Celsius scale. Out here, you're within a handful of degrees of that ultimate cold. Ices that we think of as permanent, that behave like solid rock, and gases that we cannot imagine as anything but air, all lie frozen and still. There is essentially no warmth reaching these places. The sun's heat, spread across such an enormous distance, arrives so weakened that it might as well not arrive at all. The second thing is the slowness. Everything you have ever watched move, a car, a bird, a planet crossing the sky, moves because it has energy, and the amount of energy an object has in its orbit depends on how close it is to the sun. Out here, that energy is almost gone. An object at 500 or 1,000 astronomical units creeps along its orbit at a few hundred meters per second or less, a fraction of the speed of a rifle bullet, and across the whole span of a human lifetime it barely shifts its position against the background stars. This is not a minor detail. It is the single biggest reason these worlds are so hard to find. When astronomers hunt for distant objects, they take images of the same patch of sky on different nights and look for the one point of light that has moved. A Kuiper belt object shifts enough to catch, but an object out in the far scattered disk moves so little from night to night that it is nearly indistinguishable from the fixed stars around it. It hides not by being invisible, but by being still. The dark out here is not just an absence of light. It is an absence of motion, a place where things move so slowly that they blend into the frozen background and vanish. And that slowness compounds with distance to make these regions almost perfectly concealing. To see an object at all, sunlight has to travel all the way out to it, reflect off its dark surface, and travel all the way back, and the amount of light that survives that round trip falls off ferociously with distance. Double the distance and the object grows roughly 16 times fainter, because the light weakens on the way out, and again on the way back. An object twice as far as Sedna is not half as hard to see. It is more than an order of magnitude harder. This is why our maps of the outer solar system are so thin. It is not that the objects are not there. It is that each step outward makes them exponentially fainter and exponentially slower, until they fall below the threshold of everything we can detect, still real, still orbiting, simply beyond our reach. The emptiness of the middle distance is, at least in part, a measure of our own blindness. And the third thing is the dark itself. This is the part that is hardest to truly picture, so I want us to go there together, to stand on the surface of Sedna at the farthest point of its orbit and see it with our own eyes. You're standing on a reddish frozen crust, harder than any rock on Earth, colder than almost anywhere the sun's family reaches. Beneath your feet is a world that has not been this far from the sun in over 5,000 years, and will not begin falling back toward the light for thousands more. Above you, the sky is not the soft black of a night on Earth. It is absolute total darkness, scattered with more stars than you have ever seen, sharp and unblinking, because there is no air to soften them and no glow of daylight to wash them out. And somewhere among those countless points of light, you are looking for the sun. Not a warm disk in the sky, not a source of daylight. You're searching the starfield for the single brightest point, and when you find it, it is just that, a point, blazing white but small, so small that if you raised your thumb at arm's length, you could cover it completely and blot out the only source of warmth your world has ever known. It casts the faintest shadow behind you, a shadow so dim you can barely tell it is there. It gives you no heat you could ever feel. From here, the sun that made you, the star your entire planet orbits, the center of everything you have ever called home, is indistinguishable at a glance from the other stars. You would have to know exactly where to look to find it, and this frozen ground beneath your feet, this silent world at the edge of an endless dark, still belongs to that faint star. It is still, by every law of physics, part of our solar system. You are home. You just cannot tell which light is the one you came from, and here is something the view does not show you, but that you would feel in your bones if you stayed. You are alone out here in a way that has no equal anywhere in human experience. On Sedna at Aphelion, the nearest other sizable object might be tens of millions of kilometers away, or far more, invisible against the dark. There is no wind because there is no air. There is no sound because there is nothing to carry it. There is no weather, no seasons in any sense you would recognize, no change from one century to the next except the almost imperceptible shifting of the stars as the world crawls along its orbit. If you stood here and waited for something to happen, you could wait 10,000 years and watch the sun grow slowly brighter as you fell back toward it, and that would be the only event in all that time. This is the pace of the outer solar system. It is not just cold and dark, it is slow beyond any human sense of time, a place where a single day of change would have to be measured in centuries. Stand in that for a moment before we move on, because it holds one of the deepest strangenesses of this whole subject. We think of the solar system as a warm, lit place, defined by the sun, organized around it, bathed in its light. But most of the solar system is not warm, and it is not lit. Most of it is exactly like the view from Sedna's Aphelion, a place where the sun is just another star, and the cold is nearly absolute and the darkness is total. The bright, warm, daylit part that we live in, the part where the sun is a real sun that you cannot look at directly, is the exception. It is a small anomaly of light and heat at the very center of an enormous dark structure. We did not grow up thinking of it that way, because we only ever see the exception. But if you could take an average across the whole solar system, across all its volume, the typical place in it is cold beyond imagining, black, silent, and so far from the sun that the sun is barely more than a star. That is the normal condition of our home. The daylight we take for granted is the rare thing. We are the anomaly. Everything about the way we picture space, as a bright and busy place organized around a warm central sun, is a story told from inside the one small lit room by creatures who have never stepped out of it. Step out, even as far as Sedna, and the true character of the solar system reveals itself, and it is not bright and busy. It is cold and dark and immense and patient and almost entirely empty of the warmth we assume is everywhere. The sun does not fill the solar system with light. It illuminates a tiny bubble at the center and leaves the rest in a darkness so complete that its own worlds cannot pick it out from the stars. And even Sedna's farthest point, remember, is not the edge. It is not even close. From 936 astronomical units, we still have to travel outward by a factor of 100 or more before we reach the true outer boundary of the Sun's domain. Sedna's aphelion, that place of near absolute cold and near total darkness where the Sun is a pinpoint, is the inner doorway to the largest structure the Sun owns. Beyond it lies the shell, the great sphere of frozen comets that wraps entirely around the solar system, a structure so immense that no human being has ever seen it, and that we know is there only because, every so often, it drops one of its members inward toward the light, and we watch it fall. That shell is where we go next, and understanding it changes the shape of the solar system from a flat disk into something far larger, far rounder, and far stranger than any diagram has ever shown you. Now we come to the largest thing the Sun owns, and the strangest, because it is a structure we have never once directly seen. It is called the Oort cloud, and if it were somehow made visible in the sky, it would completely change how humanity thinks about its place in space. Everything we have discussed so far, the belt, the cliff, the scattered disk, even Sedna on its enormous loop, lies in roughly the same flattened plane as the planets, the plane of that childhood diagram. The Oort cloud does not. The Oort cloud is a sphere. It is the immense, roughly ball-shaped shell of icy bodies that surrounds the entire solar system in every direction at once, above and below and all around, wrapping the Sun and all its planets and all its belts inside it, like the shell of an egg wrapped around its yolk, and it is enormous beyond anything we have discussed tonight. Let me give you the dimensions, and then let me put them in terms you can actually feel. The inner edge of the Oort cloud begins somewhere around 2,000 astronomical units from the Sun, out past everything we have visited. Its main body extends outward from there to perhaps 100,000 astronomical units, and by some estimates farther still. 100,000 astronomical units is a distance so large that the astronomical unit stops being a useful ruler for it. So let us switch to light years. The outer Oort cloud, at 100,000 astronomical units, is about a light year and a half from the Sun, and the nearest star to us, Proxima Centauri, is about 4¼ light years away. Do you see what that means? The Sun's shell of comets reaches better than 1/3 of the way to the next star, by some estimates closer to halfway. The Sun's territory does not stop somewhere out past the planets in a tidy little bubble. It reaches out across the interstellar gap, so far that if you drew the true solar system to scale, it would not be a disk of planets with some debris at the edge. It would be a sphere nearly 3 light years across, with all the planets and all the belts crammed into a single bright dot at the very centre, invisible at that scale, and the whole rest of that enormous sphere given over to the dark cloud of comets. The cloud is thought to have 2 parts, and the distinction matters. The outer Oort cloud, from perhaps 20,000 astronomical units outward, is the roughly spherical shell we have been describing, so loosely held by the Sun that it responds to the gravity of the wider galaxy. But there is also an inner region, sometimes called the Hills cloud, after the astronomer who proposed it, reaching from about 2,000 to 20,000 astronomical units, which is more tightly bound and somewhat more disc-shaped, a denser reservoir that is thought to slowly resupply the outer cloud as its members are lost to the galaxy over time. And this inner region is important for a reason we have already met, because Sedna, on its long loop out to 936 astronomical units, may well be one of the closest inner Oort cloud objects we have found. Sedna, in other words, may be our first direct sight of a member of this great shell, caught during the tiny fraction of its orbit when it dips close enough for us to see. If so, then everything strange about Sedna's orbit, its detachment from Neptune, its enormous stretch, is not an anomaly at all. It is what an Oort cloud object looks like, and there may be 1 trillion more like it, hidden in the dark beyond our sight. How the cloud came to be is itself a story of violence and rescue. The comets in it were not born out there. They formed much closer in, among the giant planets, and during that same ancient upheaval that reshaped the outer solar system, they were flung outward by the gravity of Jupiter, Saturn, Uranus, and Neptune. Most were thrown so hard they escaped the Sun entirely and were lost to interstellar space. But some were flung onto enormous orbits that carried them far out, and out there, at tens of thousands of astronomical units, the gentle gravity of the passing galaxy and of nearby stars slowly lifted and rounded their orbits, detaching them from the planets and settling them into the great spherical shell. The Oort cloud is, in a sense, made of the survivors of an ejection, the comets that were thrown almost all the way out of the solar system but not quite, and then gently caught and held by the combined pull of the galaxy at the very outer limit of the Sun's reach. It is a shell of near refugees, hanging at the edge of the Sun's ability to keep anything at all. How many comets? The estimates are almost impossible to hold in the mind. The Oort cloud is thought to contain something on the order of 1 trillion icy bodies, larger than about a kilometre across, and possibly many more than that. 1 trillion. And yet, for all that number, the total mass of the cloud adds up to only a few times the mass of the Earth, because those trillion comets are spread across such an unthinkable volume that they are almost unimaginably far apart from one another. In the Oort cloud, a typical comet's nearest neighbour might be tens of millions of kilometres away, farther than the distance from the Earth to the Sun. If you were standing on one Oort cloud comet, you would almost certainly not be able to see another one at all. Each frozen body drifts alone in the dark, so isolated that the concept of a cloud almost feels wrong. It is less like a cloud and more like a scattering of individual grains through a volume so large that the grains essentially never meet. But there are 1 trillion of them, and together they form the outermost and largest structure of the solar system. And these comets are not mere lumps of ice. Each one is a preserved sample of the early solar system, a frozen mixture of water ice, frozen carbon dioxide, methane, ammonia, and a rich variety of organic molecules, all bound together with rock and dust into what astronomers once fondly called a dirty snowball. Because they have spent the entire life of the solar system in the long freeze of the outer dark, they have never been cooked or altered, which means the material inside a comet is essentially unchanged from the cloud that formed the Sun and planets. When a comet finally falls inward and we study its glowing tail, we are reading the original chemistry of our own origins. There is even a serious idea that comets like these, crashing into the young Earth billions of years ago, may have delivered a significant fraction of our planet's water, and some of the organic building blocks that life would later be made from. If that is true, then the water in your body, the water in every ocean, may have begun its existence as ice in exactly the kind of frozen body that now waits, by the trillion, in the shell at the edge of the Sun's reach. The outer dark is not only part of our home, it may be part of us. Here is the part that makes the Oort cloud almost eerie. We have never seen it. Not one telescope, not one spacecraft, not one instrument has ever directly imaged an object sitting out in the Oort cloud in its natural place. It is too far, too dark, too cold, and its members are too small and too widely scattered to detect where they live. Everything we know about the Oort cloud is inferred. We know it is there the way you know someone has been in a room you left empty, not because you saw them, but because things have been moved, and the things that get moved, the evidence that reveals the cloud's existence, are the comets. Every so often, one of those trillion frozen bodies is nudged out of its slow orbit and begins to fall inward toward the Sun, and after a journey that can take millions of years, it comes blazing into the inner solar system, grows a glowing tail as the Sun's heat boils off its ancient ices, and appears in our night sky as a comet. And when astronomers trace the orbits of these long-journey comets backward, the orbits point back to a source that is spherical, surrounding us in every direction, at distances of tens of thousands of astronomical units. The comets are the messengers. The Oort cloud is the sender we have never seen. The person who first understood this was a Dutch astronomer named Jan Oort, who in 1950 studied the orbits of long-period comets and realized they were telling a consistent story. They arrived from all directions, not just the plane of the planets. They came from enormous distances, and there were far too many of them, arriving too steadily over human history to be explained any other way than by a huge reservoir of comets surrounding the solar system, quietly feeding a few inward every so often. An Estonian astronomer named Ernst Öpik had proposed something similar back in 1932, which is why the structure is sometimes called the Öpik-Oort cloud. But here is the remarkable thing about that discovery. Jan Oort deduced the existence of the single largest structure in the solar system, a shell of 1 trillion comets reaching halfway to the next star, without ever seeing any of it, purely by reasoning carefully about where the comets in our sky must be coming from. It is one of the great feats of inference in the history of science, and it means that the biggest thing the Sun owns was discovered not with a telescope pointed at it, but with a mind working out what had to be there. So let us fix the true shape of the solar system in our minds, because it is nothing like the diagram. Picture the Sun at the centre, picture the planets, all 8 of them, and the Kuiper belt beyond them, all of it flattened into a thin disk, and shrink that entire disk down until it is a single bright point, because at the scale of the whole solar system, that is all it is. Now, around that point, in every direction, above and below and all around, picture an immense spherical shell of 1 trillion dark frozen comets, reaching outward a light-year and a half in all directions, halfway to the stars. That sphere is the solar system. The bright, flat, familiar part we have always been shown is a speck at its heart. And the sphere is not inert. It is not sealed off from us. Because those comets that fall inward do not fall on their own. Something has to push them. And when we ask what pushes them, we find that the outer dark is being stirred right now by forces that reach it from even further away, from the galaxy itself, and from other stars. That is where we go next, and it is where the great cold shell stops feeling like a distant border and starts feeling like something that can reach all the way back to us. Because a shell that sends comets is a shell that can be disturbed, and the things that disturb it are not always gentle, and they are not always far away. Some of them come close enough to touch us, and some of them already have, within the span of human memory. The shell that wraps the solar system is not a still, dead thing hanging at the edge of the dark. It is being worked on constantly by forces larger than the sun itself, and it answers those forces by sending its frozen messengers falling inward toward the light. Every comet you have ever seen, or ever will see, is a messenger from the outer dark. When one of those trillion frozen bodies in the Oort cloud is nudged out of its slow, distant orbit, it begins to fall inward toward the sun, and that fall is not quick. A comet dropping from tens of thousands of astronomical units can take millions of years to reach the inner solar system, and when it finally arrives, when the sun's warmth reaches it and boils the ancient ices off its surface into a glowing tail that stretches across the sky, we are witnessing the end of a journey that began before there were human beings to look up. The comet in your sky tonight may have started falling toward you, while our ancestors were still learning to walk upright. It is a piece of the outer shell, delivered to your doorstep after a fall longer than the history of our species. We can actually tell from a comet's orbit which part of the outer solar system sent it. The comets that arrive on long-stretched paths from every direction in the sky, with periods of thousands or millions of years, are coming from the spherical Oort cloud, which is why they can appear from anywhere, from above the plane of the planets or below it from any angle at all. The comets that arrive on shorter, more regular orbits, tracking closer to the plane of the planets, like Halley's Comet with its 76-year cycle, come instead from the flatter Kuiper belt and scattered disk. So the sky itself sorts the messengers for us. The random, all-directions comets are letters from the Great Sphere. The orderly, plane-hugging comets are letters from the inner belt. Both are pieces of the outer dark, falling inward, telling us that the regions we cannot see are real and populated and occasionally in motion. But here is the question that opens the door to something genuinely unsettling. What nudges them? A comet sitting in the Oort cloud is in a stable orbit. It will circle the sun quietly for billions of years unless something disturbs it. So what reaches out, tens of thousands of astronomical units from the sun, and gives a frozen comet the tiny push it needs to begin falling inward? The answer is that the Oort cloud, out there at the very edge of the sun's grip, is so loosely held that it feels forces from beyond the solar system entirely. The first is the gravity of the galaxy itself, the combined pull of all the billions of stars of the Milky Way, which produces a gentle tide that slowly stretches and stirs the cloud. The second, and the more dramatic, is the passage of other stars. Stars are not fixed in the sky. They move, and the sun moves, and every so often on timescales of hundreds of thousands or millions of years, another star drifts close enough to the sun to reach into the Oort cloud with its gravity and stir it, sending a shower of comets falling inward. And this is not a hypothetical. This has happened, and it has happened recently in cosmic terms, well within the age of our own species. There is a small dim red star, part of a binary pair, catalogued with the name Y0720, and better known as Schultz's star. We have reconstructed its path, and about 70,000 years ago, that star passed through the outer Oort cloud, coming within about 52,000 astronomical units of the Sun, roughly 8/10 of a light-year. Let me put that in human terms. 70,000 years ago, anatomically modern humans were already here. Our ancestors were living and hunting and looking up at the night sky, And while they did, a star was passing through the outer reaches of our own solar system, drifting through the shell of comets that surrounds us, its gravity gently disturbing untold numbers of them. Some of the comets that Schultz's star nudged during that passage may still be falling inward now. Their journey takes so long that a push delivered 70,000 years ago produces comets that will not arrive in our skies for hundreds of thousands of years yet. The disturbance is still unfolding. The galaxy's own gravity plays a quieter but even more constant role, and it is worth understanding because it is happening all the time rather than once every few 100,000 years. The Sun sits inside the disk of the Milky Way, and the combined gravity of all the stars and gas in that disk produces a subtle, ceaseless tide, in the same way that the Moon's gravity produces tides in Earth's oceans. This galactic tide is far too weak to affect the planets, or even the Kuiper Belt. But out in the Oort cloud, where the Sun's own grip has grown so feeble, the galactic tide becomes a real force, slowly stretching and reshaping the orbits of the comets, gradually lowering the closest approaches of some of them until they begin to fall inward. Most of the steady trickle of long-period comets we see is thought to be delivered not by dramatic stellar passages, but by this quiet, relentless tide, the galaxy itself gently wringing comets out of the Sun's outermost shell, one at a time, forever. The outer dark is being stirred by the Milky Way as a whole, and has been without pause for 4.5 billion years. There is a shadow that falls across this subject, and honesty requires that we name it. If passing stars and the galactic tide can send comets falling inward, then some of those comets, across the long history of the Earth, must have struck our planet. Comet impacts are real, and a large one would be catastrophic. This has led some scientists to wonder whether comet showers from the Oort cloud, triggered by periodic disturbances, might be linked to some of the mass extinctions in Earth's past. It is a genuinely studied question, and I want to be careful and truthful about it, because it is easy to make it sound more certain than it is. The evidence for any regular clockwork pattern of extinctions is statistically weak, and most scientists do not think the fossil record shows a reliable comet-driven rhythm. But the underlying physics is not in doubt. The Oort cloud is a reservoir of 1 trillion icy bodies. It is stirred by forces from beyond the solar system, and it does drop comets inward, and some of those comets do cross the Earth's path. The outer dark is not just beautiful and remote. It is, in a real and physical sense, connected to the history of life on this planet and to its possible future. I want you to stand out there and watch it happen, because the scale of it is difficult to feel from a number alone. Imagine you are floating in the outer Oort cloud, a light year from the Sun, surrounded by the 1 trillion scattered comets, each one so far from the next that you cannot see a single one. The Sun behind you is a bright star, nothing more, and now, over tens of thousands of years compressed into a moment, another star approaches. It is a dim red ember, cool and faint, drifting slowly across the dark, and as it slides through the outer shell at 1/5 of a light year, its gravity passes across the whole enormous cloud like a hand passing over a field of grass. Nothing collides, nothing shatters. There is no flash, no impact, no sound. But across a volume more than a light year wide, 1 trillion frozen comets feel their orbits tugged, just slightly, just enough. And somewhere in that shell, one comet's slow circle is bent by the faintest fraction, enough to turn its path from a stable loop into a long inward fall. It begins to drop toward the Sun, silently, and it will fall for 1 million years, and at the end of that fall it will blaze into light in the sky of a world that does not yet exist as we would know it. That is how the outer dark reaches back toward the centre, not with violence, but with a whisper of gravity that takes 1 million years to arrive, and the traffic runs in both directions. If passing stars can push comets out of our Oort cloud, and if the giant planets long ago flung most of the original comets clear out of the solar system entirely, then the same must be true of every other star with its own cloud of icy debris. Space between the stars is not empty of these objects. It is drifting with them, cast-offs from 1 billion other systems, and every so often one of them passes through our own. We have now caught 3 of them in the act. In 2017, an object we named Oumuamua came tearing through the inner solar system on a path that could only have come from interstellar space, the first confirmed visitor from beyond our Sun's domain. In 2019, a second one, a comet named Borisov, followed, and in 2025, a third, catalogued as 3I Atlas, was detected doing the same. 3 visitors in less than a decade, which tells us these interstellar wanderers are not freak events, but a steady ongoing trickle. The lesson is quietly profound. The boundary of the solar system is not a wall that keeps our objects in and everyone else is out. It is porous. Things leave and things enter, and the great shell at the edge of the sun's reach blends at its outermost limit into the general drift of the galaxy. We are not a sealed vessel. We are a slightly denser patch in a much larger sea, and the sea flows through us. Sit with what that truly means, because it changes the outer dark from something remote into something connected to us. We tend to imagine the far reaches of the solar system as sealed off, as a border that stays put, as somewhere that has nothing to do with the warm inner room where we live. It is not sealed off. It is in constant, slow communication with the space around it, and with us. Other stars pass through it. The galaxy pulls on it, and it responds by dropping comets inward, comets that cross the entire solar system and arrive in the very sky above your head. A star that grazed the sun while your distant ancestors were alive can still be sending you comets, and there are more such encounters coming. A star called Gliese 710, a modest orange star, is currently on a path that will carry it far deeper into the Oort cloud than Schultz's star ever came, passing within about 13,000 astronomical units of the Sun in around 1.3 million years, close enough that astronomers expect it to trigger a genuine comet shower. The outer dark is not finished touching us. It has appointments still to keep, written in the motion of the stars, and it will keep them long after we're gone. Think about that the next time you see a comet or a photograph of one. That bright, silent visitor is not a stranger passing through. It is a piece of our own solar system, from a shell so far away that no human eye has ever seen it, sent inward by the pull of the galaxy or the passing of a star, arriving after a fall that may have lasted longer than our entire species has existed. It is a letter from the edge of home, and the return address is a place we have never been able to visit and may never be able to reach. The dark writes to us. We have simply never learned to see where the letters come from. We come now to the deepest unease the outer solar system has to offer, and it is not about distance, or cold, or darkness. It is about ignorance. It is the real, ongoing, unresolved possibility that a planet, a genuine planet larger than the Earth, is orbiting the Sun right now, out in that dark, and that despite everything, despite every telescope and every survey, and more than a decade of dedicated searching, we cannot find it. Not because it is too small, not because it is impossible, simply because the space it would be hiding in is so enormous and so dark that a whole world can vanish into it. Let me take you back to the clue we set aside earlier, the alignment. When astronomers plotted the orbits of the most extreme detached objects, the sednoids and their kin, out on their enormous stretched loops, they noticed that the orbits were not pointing in random directions. They seemed to be clustered. The long axes of these orbits, the direction in which each one stretches out toward its farthest point, appeared to line up, tilting the same way and pointing the same way in space, far more than random chance should allow. In 2016, 2 astronomers at Caltech, Konstantin Batygin and Michael Brown, the same Mike Brown who had found Eris and Sedna, studied this clustering and made a bold argument. The alignment they proposed was not a coincidence. It was being maintained by the gravity of an unseen planet. A large body orbiting far out in the dark could gravitationally shepherd these distant objects, herding their orbits into the aligned pattern we see in the same way Neptune shepherds the Plutinos. They calculated what that planet would have to be like, and the answer was striking. Something in the range of 5 to 10 times the mass of the Earth, a world larger than our own, orbiting at a distance of roughly 400 to 800 astronomical units, taking somewhere between 10,000 and 20,000 years to circle the Sun once. They called it Planet 9. Here is why this idea is so hard to shake. Remember the fingerprint. Remember that an orbit is a record of every force that has acted on an object. When we looked at Sedna alone, its orbit told us that something had reached out and shaped it. But a single strange orbit could have many explanations. A passing star long gone, the Sun's birth cluster, chance. But this is no longer a single orbit. This is a whole population of distant objects, all bearing the same signature, all pointing the same way, as though the same hand had shaped every one of them. One aligned orbit is a curiosity, A dozen aligned orbits is a pattern, and a pattern demands a cause that is still present, still acting, still out there maintaining the alignment against the slow tendency of orbits to drift apart. That is the case for Planet 9. It is written not in one fingerprint, but in many, all matching, all pointing back toward the same unseen shaper in the dark. And if it is real, think about what it would mean. Planet 9 would be the 5th largest planet in the solar system, larger than Earth, larger than Venus, a substantial world, and it would have been hiding in our own solar system this entire time, not in some distant galaxy, not around another star, here, at home, bound to our own sun. The reason we have not seen it is simply that at 400 to 800 astronomical units, sunlight is so feeble, and the reflected light making the long journey back to us is so faint that the planet would shine at the very limit of what our telescopes can detect, moving so slowly across the sky that it is desperately hard to distinguish from the fixed stars. It could be a faint dot sitting in images we have already taken, unrecognized, waiting for someone to notice that one point of light is very slowly moving. The search has been relentless, and in the last few years it has intensified. In 2025, a team led by the astronomers Terry Long-Fan and Tomotsugu Goto tried a clever approach. They took 2 infrared surveys of the whole sky, one from a satellite called IRAS in 1983, and another from a satellite called Akari taken between 2006 and 2011, more than 20 years apart, and they searched for an object that had shifted position between the two at just the rate a distant planet should. And they found a candidate, a single faint infrared source that appeared to have moved, consistent with the distance and mass range predicted for Planet 9. I want to be careful here, because a candidate is not a confirmation. 2 snapshots taken 23 years apart give only a rough sense of an object's path, not a locked orbit, and the candidate still needs targeted follow-up observations to prove it is really there and really orbiting the Sun. But it is the most concrete lead the search has produced, and it has sharpened the sense that the answer may finally be within reach, and the answer is coming, one way or another, very soon. In the mountains of Chile, a new telescope called the Vera Rubin Observatory has recently begun its work, carrying the largest digital camera ever built, designed to photograph nearly the entire southern sky over and over again, night after night, for 10 years. It is almost purpose-built to find slow-moving objects in the outer dark. Astronomers estimate that if Planet 9 exists, the Rubin Observatory has something like a 70 to 80% chance of finding it. Within the next few years, this decade-long question is likely to be settled. Either we'll finally see the planet that has been hiding in our own solar system, or we will search the sky so thoroughly that its absence becomes hard to explain, and we will be forced back to the drawing board to ask what else could have shaped those aligned orbits. Because in fairness, the story has grown more complicated, not less, in the last 2 years, and honesty requires that I tell you so. As astronomers have found more distant objects, some of them have not fit the pattern. In 2025, a large object called 2017 of 201 was announced, a possible dwarf planet some 700 kilometers across, out on an orbit reaching into the inner Oort cloud, and its orbit points in a direction outside the predicted clustering. Then, in June of 2026, an object nicknamed Ammonite was announced, a 4th sednoid found by the Subaru telescope, and its orbit too is misaligned with the others, which actually weakens the clustering evidence that pointed to Planet 9 in the first place. So the picture right now is genuinely unsettled. Some of the evidence supports a hidden planet. Some of the newest objects undercut it. The people who know the most about this disagree in print about whether the planet is there at all. It is worth pausing here to clear away some noise, because a hidden planet in the outer solar system is exactly the kind of idea that attracts frightening stories that are not true, and the real science is unsettling enough without them. You may have heard, over the years, of a doomsday world called Nibiru, or Planet X, said to be on a collision course with Earth, due to arrive on some predicted date and cause catastrophe. It is important to be clear that this has nothing to do with Planet 9. Planet 9, if it exists, is proposed to orbit at 400 to 800 astronomical units, and never to come anywhere near the inner solar system. It is the opposite of a world plunging toward us. It is a world so distant it takes 20,000 years to complete one slow, far-off loop. There is no object known to be on a collision course with Earth, and a large incoming body would have been spotted years or decades in advance by the same infrared surveys that hunt for asteroids and comets. Nibiru, as a doomsday planet, is inconsistent with basic orbital mechanics and with the simple fact that its supposed gravity would have visibly disturbed the inner planets long ago, and it has not. There is an older idea too, one that came from real scientists, called nemesis. In the 1980s, some researchers proposed that the Sun might have a dim companion, a faint star or brown dwarf on a very distant orbit, whose periodic passages through the Oort cloud could trigger comet showers and drive the mass extinctions some thought they saw in the fossil record. It was a serious hypothesis, and it was testable, and it was tested. Extensive infrared surveys of the entire sky, especially a mission called WISE, searched for exactly such a companion, a cool object that would glow in infrared even if it were too dim to shine in visible light. They found nothing. There is no nemesis. The Sun has no hidden stellar companion, and the supposed regular rhythm of extinctions turned out to be statistically weak. But I mention it because it illustrates something true even as the specific idea failed. The outer dark genuinely can reach in and touch the Earth, through passing stars and comet showers, just as we saw with Schultz's star. Nemesis was wrong about a permanent companion, but it was pointing at a real connection between the outer dark and life on this planet. And there is one more possibility, stranger than any planet, that a small number of physicists have floated. What if the thing shaping those aligned orbits is not a planet at all, but a small primordial black hole, a relic from the earliest moments of the universe, of about 5 Earth masses, which for a black hole would make it only a few centimetres across? Such an object would have the gravity to herd the distant orbits, but it would be almost impossible to see directly, because a black hole that's small emits no light of its own. It is considered a long shot, and most astronomers expect an ordinary planet if anything is found at all, but it has not been ruled out, and there are proposals to search for the faint flares such an object might produce as it swallows stray matter. Sit with that for just a moment. Among the serious published explanations for the pattern in the outer solar system is the possibility that our own Sun is orbited, in the dark, by a black hole the size of a grapefruit. That is how little we can rule out about the space beyond Neptune. It is dark enough and large enough to hide almost anything. And notice what that does to the horror at the centre of tonight. It does not resolve it. It sharpens it. Because there are now only 2 possibilities, and both of them should unsettle you. The first possibility is that Planet 9 is real, in which case there is a world larger than the Earth orbiting our own Sun, and we have spent more than a decade unable to find it. The second possibility is that Planet 9 is not there, in which case the strange aligned orbits of Sedna and its kin were shaped by something else, something we understand even less, a passing star we cannot identify, or a process we have not yet imagined. Either the outer dark is hiding a planet, or it is hiding a mystery deeper than a planet. There is no comfortable version of this. We are left, either way, staring at the same fact we have circled all night, which is that our own solar system contains a room large enough and dark enough to hide a world, and we still do not know what is in it. We are a species that prides itself on knowing. We have mapped the ocean floors and the human genome in the first fraction of a second after the birth of the universe, and yet we cannot say, tonight, whether there is a 9th planet orbiting our own Sun. We do not know our own address. There is something humbling in that, and something quietly frightening, because it means the confident little diagram we started with, the one with 8 tidy planets and an empty edge, was not just incomplete. It was hiding the fact that we do not yet know how our own home is furnished, and the tool that may finally answer the question is already switched on, in Chile, photographing the dark night after night. The answer, after all this time, may arrive within a few short years. We are right now in the last stretch of not knowing. We have walked a very long way tonight, from Neptune out through the belt and the cliff, past the pristine relics and the impossible orbits, across the great cold gap, into the shell of 1 trillion comets, and up to the edge of a mystery we cannot yet solve. And now we arrive at the final question, the one that has been waiting behind all the others. Where does the solar system actually end? What is the true edge? And the honest, unsettling answer is that there is no edge. Not in the way you are picturing it. There is no line, no wall, no boundary marker where the Sun's territory stops and interstellar space begins. Instead, there is a slow fading, a gradual loss of the Sun's grip, so gentle and so gradual that you could cross it without ever knowing you had. Part of the confusion comes from the fact that the solar system has more than one kind of edge, and they lie at wildly different distances. There is a boundary made of the sun's wind. The sun does not only give off light, it also blows out a constant stream of charged particles in every direction, called the solar wind, and that wind carves out a great bubble in the surrounding interstellar gas, a bubble we call the heliosphere. At the edge of that bubble, the solar wind slows, piles up, and finally gives way to the thin gas that drifts between the stars. That boundary is called the heliopause, and it sits at roughly 120 astronomical units from the Sun. It is a real and important edge, the place where the Sun's atmosphere, in a sense, finally ends, but it is not the gravitational edge of the solar system, and the two are almost comically far apart. The heliopause is at 120 astronomical units. The gravitational edge, where the Sun stops holding onto its comets, is out past 100,000. The Sun's wind gives out almost 1,000 times closer than the Sun's gravity does. So when we ask where the solar system ends, we have to be clear about which ending we mean, and the one that contains the Oort cloud, the one that holds nearly all the objects the Sun owns, is the far, far more distant one. To understand the gravitational edge, we have to think about what actually holds the solar system together, which is the Sun's gravity. Close to the Sun, that gravity is overwhelming, and the planets are held firmly in their orbits. Farther out, in the Kuiper belt, it is weaker, but still clearly in charge. Out in the Oort cloud, it has grown so feeble that, as we saw, the gravity of the galaxy and of passing stars can compete with it and stir the comets around. And if you keep going, there comes a distance where the Sun's gravitational pull finally becomes weaker than the combined pull of the rest of the galaxy, where an object is no longer reliably bound to the Sun at all. That distance, the true outer limit of the Sun's gravitational domain, is estimated to lie somewhere between 1 and 2 light-years from the Sun, out at well over 100,000 astronomical units. That is the real edge, if you insist on calling anything an edge. It is not a surface. It is the fuzzy zone where the Sun quietly loses the argument with the galaxy over who owns a given comet. Let me put that final distance in perspective, because it closes the circle on the scale we have been building all night. The nearest star, Proxima Centauri, is about 4¼ light-years away. If the Sun's gravitational reach extends to 1 or 2 light-years, then the Sun's domain reaches somewhere between 1/4 and nearly halfway to the next star, and the next star has its own domain, reaching back toward us, which means the empty space between the Sun and Proxima Centauri is not as empty or as clearly divided as it sounds. The two systems very nearly touch at their gravitational fringes. The solar system does not sit isolated in a great void with a clear boundary around it. It reaches out until it almost brushes against its neighbour, and then fades, without any dividing line, into the general drift of the galaxy. I want you to stand at that final edge with me, one last time, and look back. You're somewhere between 1 and 2 light-years from the Sun, at the very outermost limit of everything that could be called ours. Around you, the comets of the outer Oort cloud are so sparse and so faint that you cannot see a single one, and there is nothing at all to mark this place as special. There is no fence, there is no sign, there is no wall, no gate, no line drawn on the dark. And when you turn to look back toward the Sun, toward the centre of everything you have ever known, you cannot pick it out. It is not a sun anymore. It is not even the brightest star in the sky. It is one modest point of light among thousands, utterly ordinary, indistinguishable from the other stars around it unless you already knew exactly where to look. Everything, all of it, the Earth, the planets, the belts, the whole warm, bright, bustling solar system is compressed into that one dim, anonymous point. And here is the strangest part. If you drifted just a little farther out, a little farther into the dark, at some unmarked moment the galaxy's pull would quietly become stronger than the Sun's, and without any sensation, without any sign, you would stop being part of the solar system at all. You would simply belong to the galaxy instead. You could cross the edge of the entire solar system and never feel a thing, because the edge is not a place. It is a balance tipping in the silent dark. There is something profound hiding in the idea that the solar system has no true edge, and it is worth naming plainly. We're used to thinking of our home as a bounded place, a self-contained island of light with the black void of interstellar space beginning cleanly somewhere out past the last planet. That picture is false. The solar system does not end. It dissolves. It thins and fades and loosens its grip so gradually that at no single point could you ever say, "Here, this is the last of it." And because the neighbouring stars are doing the same thing, reaching outward with their own fading grips, the true situation is that the star systems of the galaxy blur softly into one another at their edges, like drops of ink spreading in water until it is impossible to say where one ends and the next begins. We do not live on a walled island. We live in the densest part of a slow, continuous drift that never fully stops anywhere. The dark between the stars is not a separate country with a border we cross. It is the same dark that fills the outer reaches of our own solar system, simply thinned a little further. To feel how far away all of this is, consider our farthest emissary. The Voyager 1 spacecraft, launched in 1977, has been flying outward for nearly 50 years, faster than almost anything humans have ever built, and in 2012 it crossed what we call the heliopause, the boundary where the sun's wind of particles gives way to the wind between the stars. Many headlines at the time said Voyager had left the solar system, but that boundary, the heliopause, sits at only about 120 astronomical units. In terms of the sun's gravity, in terms of the true structure we have been exploring, Voyager has barely stepped outside the front door. By 2026, it is about 25.5 billion kilometers from Earth, and in November of that year it will become the first human-made object ever to be a full light day away, so distant that its radio signal, travelling at the speed of light, takes about a full day to reach it. And yet, after nearly half a century of flight, Voyager has not even reached the inner edge of the Oort cloud. It will not arrive there for roughly another 300 years. It will not pass through the far side of the Oort cloud, out to the true gravitational edge, for tens of thousands of years. Our fastest, farthest spacecraft, the one that has become a symbol of humanity reaching the stars, is still, in the only sense that matters, far inside our own solar system, creeping across the first tiny fraction of the great dark shell. That is how large the space beyond Neptune truly is. We built a machine to leave the solar system, and half a century later it is still barely out the door, and even as it creeps outward, the whole solar system is itself moving. The sun does not sit still. It orbits the centre of the Milky Way at roughly 230 kilometers per second, dragging all its planets and belts and its entire trillion comet shell along with it, and it takes something like 225 million years to complete a single lap of the galaxy. Right now, the sun is drifting through a thin wisp of gas that astronomers call the local interstellar cloud, one patch of the broader medium between the stars, and in tens of thousands of years it will drift into a different patch. The outer solar system, that great fragile shell of loosely held comets, is being carried through this changing interstellar weather, like a jellyfish through a current, its outermost members constantly at risk of being stripped away or exchanged with the material around it. So the edge of the solar system is not only fuzzy in space, it is fuzzy in time, shifting and reshaping as the sun wanders through the galaxy, gaining and losing the outermost comets across the ages. There is no fixed boundary to find, because there is no fixed boundary to begin with. There is only a moving, blurring, breathing zone where our home slowly gives way to everything else. Let us come back, at the end of our long walk, to where we began. Let us come back to that simple picture of the solar system, the one almost everyone carries in their head, the neat row of planets ending just past Neptune, with nothing after it but the empty black edge of the map. We can hold that picture in our minds again now, but we cannot see it the same way anymore, because we have walked out past that edge together, step by step, and we know what is actually there. The map ends at Neptune. That was the lesson we absorbed as children, without anyone ever saying it aloud, and tonight we have learned what that ending really was. It was never the edge of the solar system, it was only the edge of what we had bothered to draw. The line at Neptune did not mark where the worlds stop. It marked where our knowledge stopped, and we mistook the limit of our seeing for the limit of the thing itself. So let us redraw the map honestly, one last time. Past Neptune, where the old diagram showed nothing, there is the Kuiper Belt, thousands upon thousands of frozen worlds, with Pluto living among them, geologically alive, its glaciers slowly turning over, mountains of ice standing in the dark, possibly an ocean hidden beneath its shell. Past the belt, there is the unexplained cliff, and past the cliff the pristine relics like Arakoth, unchanged since before the Earth was born. Past them, there are the impossible worlds, Sedna and its kin, on orbits so far from Neptune that something we have never seen must have shaped them, orbits that are fingerprints of an unseen hand. Past them, there is the long, cold gap, and then the great shell itself, the Oort cloud, 1,000,000,000,000 comets wrapped around the entire solar system, reaching a light year and a half into the dark, halfway toward the next star. And threaded through all of it, still unresolved, is the possibility of a planet larger than the Earth, hiding somewhere in that shell right now, herding the distant orbits, waiting to be found or waiting to be ruled out. That is the real map. That is the solar system as it actually is, and the bright, flat, familiar part we were shown as children, the part with the 8 planets, turns out to be a single small point of light at the very centre of a dark sphere nearly 3 light years across. Now say the words again, and feel how much weight they have gathered along the way. It's not empty. When we first stepped past Neptune and found the Kuiper Belt, that phrase was a pleasant surprise, a small correction to the diagram. But we have said it at every single step since, and each time it has meant something larger. The belt was not empty, the cliff was not the end. The scattered dark was full of worlds on impossible orbits. The great gap was crossed by wanderers on 11,000-year loops. The shell we cannot even see holds 1,000,000,000,000 comets, and the room we thought was the empty edge of everything may be large enough and dark enough to hide an entire planet from us. It's not empty. By the end of this walk, those 3 small words have stopped being a reassurance and become something closer to a verdict on how completely we misjudged the place we live, and on how much of our own home has been sitting out there in the dark the whole time, unseen, unmapped, waiting. Go back one final time to the grain of sand because it is the truest picture we have. Shrink the sun to a single grain, and the Earth is an invisible speck a centimetre away, and Neptune, the far wall of the old diagram, is about a forearm's length out, and the whole familiar solar system fits on a desk. Everything you have ever known, every person who has ever lived, every event in all of human history happened within that 1 centimetre of that one grain of sand, and the solar system, the real one, the one we have walked tonight, extends outward from that desk, past the walls of the room, past the edge of the building, out for kilometres in every direction, an immense dark sphere with a single glinting grain at its heart. That is the correct proportion of the known to the unknown in our own home. We have spent our entire existence on a speck beside a grain, and we called it everything, and only now are we beginning to look up and see how much room there is in the dark around us. And I want to be clear about where the real horror in tonight's title actually lives, because it is not where you might expect. It is not that the outer dark is cold, though it is colder than almost anywhere. It is not that it is enormous, though it is larger than any diagram has ever admitted. It is not even the possibility of a hidden planet, unsettling as that is. The real horror is quieter and closer to home than any of those. It is that all of this, every frozen world and impossible orbit and unseen comet and possible planet, is not somewhere else. It is not in a distant galaxy or around another star. It is here. It is our own solar system, our own address, the place we have lived for the entire history of our species, and we have only just begun to see it. We drew a confident little map, and we hung it on the wall, and we taught it to our children, and it left out more than 99% of our own home, and we did not even know that it had. The frightening thing about the space beyond Neptune is not that it is full of the unknown. It is that the unknown was ours all along, and we never looked. But I do not want to leave you only with unease, because there is something else in all of this, something that sits right alongside the fear and does not cancel it out. We are the first generation of human beings to know any of this. For the entire span of human history, right up until the last few decades, the map really did end at Neptune, because we had no way to see past it. And then, within a single lifetime, we found the Kuiper Belt, we visited Pluto and Arrokoth, we discovered Sedna and the impossible orbits, we inferred the great shell of comets, and we began, seriously, to hunt for a hidden planet in our own dark. We are living in the exact moment when the map is being redrawn, when the empty edge is being filled in, when the space beyond Neptune is turning, before our eyes, from a blank margin into the largest and strangest part of our home. The answer to the deepest question, whether there is a 9th planet out there, may arrive within just a few years, from a telescope that is already switched on and watching. There is a strange privilege in that, when you sit with it. Every generation before us looked out past Neptune and saw only a blank. Every generation after us will grow up with the filled-in map, taking for granted the belt and the shell and whatever the coming years reveal about the hidden planet. the way we take for granted that the Earth goes around the sun. But we're here at the hinge, in the narrow window of history when the blank is being filled, when the words "it's not empty" are being proven one discovery at a time. The comets falling inward tonight, the frozen worlds turning in the dark, the faint moving dot that may or may not be a planet, are not settled facts in a textbook. They are a story unfolding right now, in our own time, and we are the ones watching it happen. We are the ones who get to find out. So the next time you see that simple diagram, the neat row of planets ending just past Neptune, remember what is really there. Past the edge of the drawing in the dark the artist left blank. It's not empty. It never was. It is most of our home, and we are only now, after all this time, beginning to see it. And there is a certain peace in that, if you let there be. The dark beyond Neptune is not a threat looming over us, whatever the word horrifying might suggest. It is simply the larger part of the place we belong to, patient and cold and quiet, turning slowly on timescales that make a human life look like a single breath. The comets drift. The frozen worlds trace their enormous loops. The hidden planet, if it is there, continues its 20,000-year orbit as it has since before we existed, indifferent to whether we ever find it. None of it is in a hurry. None of it is coming for us. It is just there, and it has always been there, and it will still be there long after tonight is forgotten. An immense dark home wrapped around a single grain of light. So let that thought carry you gently down into sleep tonight. Let yourself drift outward, past the last blue planet, past the belt and the cliff and the impossible orbits, out through the shell of 1,000,000,000,000 silent comets, into the quiet, enormous dark that has been ours all along. There is nothing to fear out there. There is only the rest of our home waiting in the dark to be seen. Rest now. The dark will keep.